So, so you've seen AWS App Mesh presentation, and in the afternoon you'll actually see a presentation from the traffic director folks at Google, and so on. All of these are basically, manifestations of how you would deploy a service mesh across a heterogeneous environment, spanning virtual machines, your Kubernetes clusters, or ECS, EKS, and what have you. But let's say you are from the camp that cannot go to cloud or cannot use a hosted version of a service, or do not want to use a hosted version of a service. How do you go about deploying a service mesh locally on-prem that spans both brownfield and greenfield applications, whether it's your old VMs on VMware vSphere systems or spanning Kubernetes clusters on OpenShift or what have you, right? And so this, the concepts here will map directly to Istio, but this is just to distill the basic abstractions that you would actually need. So this is a typical infrastructure that you would have today. You would have a global load balancer from one of those hardware load balancer vendors, and then you would have local traffic manager equivalent load balancers for every network zone, and a bunch of firewalls in between, and a large array of vSphere ESXi installations, and a small island of Kubernetes cluster here and there where the hippies are doing some new application development. So it's the usual stuff that we've heard from almost every brick and mortar enterprise. So along comes this, and now you you want to modernize this infrastructure. You want to get to understand what traffic is flowing through, and you're tired of getting more metrics from your hardware load balancers. It becomes more clunky. So what do you do? So you start thinking of a service mesh. Hey, maybe I can do the service mesh thing, and it will probably give me more telemetry. The first misconception is that it's only for the hippies in Kubernetes world and so on and so forth, which is so not the case. In fact, the service mesh is your vehicle for workload transformation from your VM world into Kubernetes and or whether even if you don't want to move, but is something that precedes Kubernetes, because you can have a full telemetry across the system with a consistent stack. So you have to decide what you want from the service mesh in decreasing order of priority. So I would typically rank this as: you first want telemetry, you first want to see what the hell is going on in the whole island of VMs, and you want to have some traffic management things that you're doing in your load balancer today, where in the previous picture the typical traffic flow happens, traffic from this VM to the other VM always goes through the load balancer and comes back into the VM that's adjacent on the machine. So you typically want to eliminate those east-west routes, the hairpins across those things, and you want to get some telemetry and end-to-end MTLS, and then you'd want to do fancy stuff like policy enforcement and blah, blah. So with this in mind, the mesh is not free. Nothing is free, and there are some things that you would have to have in place in your on-prem deployment or in your security deployment, wherever you have. These things are the basics that you need to have before you even think of a service mesh. The first thing, of course, is basic, is that you need to have a way to get sidecars into every workload in your system, which is, whether it's Kubernetes, it's easy. If it's something else, for example, you have a whole bunch of VMs, then you need to figure out how you would get a sidecar into every VM. If you have your own imaging infrastructure with some blessed VM images and so on and so forth, figure out a way to get an Envoy process that runs on these VMs and recycle your existing VMs and replace these with the newer ones, which has this Envoy workflow that's running on each of these VMs. So that's hurdle one. Second part is that all the telemetry is not going to go into Ether. You need to have a place to store all the stuff, whether you have an on-prem version of Elasticsearch or you have some team that's going to be managing your metrics and data stores and so on and so forth. You need to have that, and without that, all of these metrics are useless. Then, and third, and the bigger one, is that you need to have an inventory. You need to know how many VMs are there, what their IPs are, and what services or DNS names that are assigned to them, and they're the essentially a service registry equivalent, what you have in a Kubernetes equivalent of here is a service foo which has these 5 backend endpoints. So you need to have a way of gathering that information. We'll see how we can get that through existing systems. And then if you want to do MTLS kind of systems, in your VM land, you need to have a way to attest workloads on these VMs. Essentially, on Kubernetes, when a pod comes up, Kubernetes can attest the fact that this pod is a valid pod, part of the Kubernetes cluster that is owned by me, and is not some random process that's claiming itself to be a pod, and so on. So in an equivalent way, on the VM LANs, like you typically have like the VMs will have an LDAP account that they would actually like when the VM comes up, it would log into LDAP or what have you. But you need to have similar mechanisms in your VM LAN if you want to do the MTLS, where the workload, basically a VM that comes up, can attest itself that this is probably like, it's a proper VM and it's not some malicious workload. And some way to deliver certificates to these VMs, whether you happen to embed them inside the as machine certs, or do you have a like giant NFS mount that spreads certificates across, it's up to you. So with these as the background requirements, like let's look at just a recap in terms of like how VMs versus Kubernetes differ when you start thinking about a service mesh. Sidecar injection, it's a breeze in Kubernetes. You can automatically inject sidecars, whereas when you get to the land of VMs, you have to go talk to the VM imaging department. Inventory, yes, inventory is like, after having talked to a whole bunch of customers, some have completely like database-based inventories with some portals where you go and register services and create those DNS accounts and so on. Some don't even have that, and it's a wide open world there. And workload attestation, the tools at your disposal today are like LDAPs or machine certs or HSMs that are attached to these VMs and so on. On Kubernetes, it actually comes built in for the pods. And certificate delivery, once again, it's through secrets and other agents on Kubernetes, but this is something that you would have to work out. So with these, let's say you have these things sorted out. Then how do we go about, let's say, deploying a service mesh completely on-prem that spans both brownfield and greenfield? Let's start with gathering inventory to know what these services are and what these backend IPs are. So you typically have these hardware load balancers. One simple way to gather inventory is use the APIs that these load balancers support and read the list of all virtual servers that they have, which is the DNS name that they would have, and the list of all backend IPs from their load balancing pools. This would serve as a decent authoritative version of source of truth, where you can get all information about what are these services, what are their backend endpoints that you need to have. In addition, you can read the same inventory from Kubernetes to get a giant list of like, here are my 5,000 services and 15,000 endpoints that are there in the system. So in Istio terms, like, you would write, like, we would have some adapters that would read from your hardware load balancers and load it up into some backend database that would get read by a system like Galley, and it would just get served to Pilot and so on and so forth. The second piece is deploy your control plane. So you need to decide how you want the control plane deployments to be. If your systems are small, or if you happen to have a more like an NSX network, based network topology that actually spans across different things, you might want to go down the local control plane and the global control plane model, where you have one global control plane that controls the inventory, that controls all the configurations that you would do for something like Istio, where you say like traffic from here to there should go X and Y and so on. And this configuration would actually be adorned with more like, LDAP login controlled, SSO controlled, and so on and so forth. So you build all that stuff on top. Then these global mesh control planes would actually send the respective configurations to a pilot that's deployed in each and every zone, so that it can actually transmit the configurations to every Envoy sidecar in Kubernetes or the VM LAN. In case you don't want that, the two-tier thing, you can still go with a single centralized bunch of like control plane deployments, where everything talks to the centralized control plane, and you'd get your and as long as the sidecars can get their configurations from from Pilot, you're good to go. And then this is where the fun starts. So on Kubernetes land, getting the sidecars in and getting all the other stuff in is a breeze. You just have a gateway and you have a bunch of sidecars, and you'd actually get to see telemetry very easily. What happens on the VM LAN? So it might take you months or much longer in order to get the sidecars get rolling on every VM inside the system. In the meantime, the thing that you can do so that you can at least get telemetry is you can actually route all your load balancer traffic via a pool of gateways, which is basically like envoys running on VMs. It's a pool of VMs, and all your traffic from your load balancers would flow through these VMs, and which in turn would load balance amongst all the actual virtual machines on your deployment. So this would at least give you synchronized telemetry across Kubernetes and VMs alike, and you'd actually be able to see how traffic is flowing and what services are there and what APIs are present, and it gives you a lot more, it at least gives you full visibility than what you would get from the load balancers today. So for example, Then you can start looking at the telemetry dashboard to see, oh, I did not know that this service exists on my VM land, and like, who the hell created this thing? And so there's a whole bunch of things that would happen, but there is immediate value by simply deploying a bunch of gateways in front of your VM clusters, and so that you can actually get a whole bunch of information. And then, so once you have that, then you start gradually introducing sidecars into each and every VM, and this is where you get benefits like east-west traffic directly going from like VM to VM, and instead of going through the hairpins, and other things that would automatically flow with it, like traffic management and MTLS and policy enforcement and whatnot. But this is the gradual progression that you would follow, and it's not a day-to-day, one-day replacement overnight. So now let's get to the sidecar like deployment on VMs. So like most enterprises today, you cannot just bring some Tom, Dick and Harry binary and just stick it in a VM, because you would have like blessed builds and like it's FIPS certified and comes through like some certain legal stamping and all the other bullshit that goes with this whole system. So the first order of business is you need to get an Envoy build that actually like works with your OS distribution, with your particular RHEL version or CentOS version and so on, and preferably one which is FIPS certified, which has a whole bunch of compliance stamps present that legal can be like happy with and maintain. So we did a packaging of Envoy, which with the custom build of Envoy, which has like an OpenSSL based like FIPS certified compliant builds, and we will actually track the CV vulnerabilities, and we'll actually send you updates saying, hey, this thing is old or this thing has bug fixes and issues. So that part is taken care of for you. But what you would have to do is like in your VM imaging infrastructure, you would have to get Envoy from this, get Envoy like the site, and you'd actually package it as part of your VMs. And once you have this, then the second part is how do you capture traffic inside a VM? So there's no point in simply running an Envoy, nothing is going to magically flow through it. You have to make sure all your application traffic flows through this Envoy in order to be able to see what is happening in your VMs. So there are few approaches here. One is you can take the same approach that Istio is doing on Kubernetes with pods, which is install IP tables and capture all traffic that enters VM and leaves the VM and route it through Envoy. I would not advise you to do that, because it's a nightmare to do it, because there is a lot more traffic that happens in a VM than what is listed on the service registry. Things like basic NTP updates, or just going and talking to some local server, APT get updates and patch servers and so on and so forth. Everything would end up being captured, and if you try to prune the IP tables, it's just like sinking yourself into a pit. Instead, the quick and dirty and line share version of it is like if you just set the HTTP proxy environment variable, which is supported by most languages, you would get most of the traffic that flowing through Envoy, and which would actually get you a large portion of traffic. But there are some wrinkles here as well, which I'll get to it in a bit. An alternative option is like you can explicitly configure Envoy to listen on some particular port, let's say 9080, and then you change all your load balancers to route to port 9080, and Envoys will route to the actual application port, and you can do the vice versa on the way out. So this would require some application changes, but this is like may or may not require application changes, but this is up to you. The choice of like whether you want to do a white box mode capture, whether you want to simply set an HTTP proxy environment variable and forget about it, is totally up to you. Now this is where like you need to see whether having a sidecar is actually going to be useful or not. There is a wrinkle here, which is that this works if you're just having a simple standard Java application server, which is just receiving traffic over HTTP and sending traffic back on HTTP and so on. But there's a large class of people who have things like WebSphere, WebLogic clusters, JBoss clusters, and so on and so forth. These things do not simply talk over HTTP on east-west. They have their own clustering mechanism. They build their own equivalent of like a Kubernetes version, a much more robust version back in the late 90s and 2000s, and so they have more optimized protocols for replication, session state replication, and so on and so forth. So these are proprietary binary protocols, and it's just like Akka clusters. So they have their own clustering mechanism, and there is nothing that you can do that would actually get you some visibility into this. In those cases, I don't think there's any point in deploying a sidecar on these VMs, except for possibly like getting MTLS traffic. But beyond that, you won't get much benefit out of those scenarios. You need to keep that in mind before you decide whether you want sidecars on those VMs or not. Basically, it depends on the workloads and the kind of things that you actually have. And so look at the traffic, but in those cases, it definitely makes sense to at least have the Envoys as a gateway pool, because you at least get telemetry for traffic, not out traffic. Stuff that's coming into those VMs is typically going to be HTTP and not either binary protocols. And of course, the updates is like you have to figure out an update strategy. Just like the way you do patch management for VMs, you can just bake this part into the same patch management processes, saying that if this Envoy needs to be upgraded, you recycle the VMs and you update the new ones in place. So that's basically it. I mean, like there's not much left in terms of like, modernizing your brownfield infrastructure. This is not a Kubernetes only concept. In fact, you start with a service mesh and then you work your way to Kubernetes or whatever it is that you happen to go to. So figure out a way to get sidecars into every workload if need be, like depending on this, and figure out a way to get the inventory, and you should be all set. So questions? That's it? No questions? Yeah. Yes, basically yes. Mm-hmm. Mm-hmm. So SSL termination of the load balancer is actually relatively straightforward because you have a process in your company to mount certificates on those load balancers. You do the exact same process to mount certificates on the VM appliances that are running Envoys. So there is no change in process. You can do SSL termination in the load balancer in Envoys, or if you were to replace the load balancer. But if you're not replacing the load balancer, if you just simply have the load balancer and then routing all traffic via this pool of Envoys, then Envoys is going to receive HTTP traffic. So you don't have to worry about TLS termination within Envoys either, right? Yes, yes. Any other questions? Somebody. Okay.
All right, cool. Thank you.
Yep. Okay.
Cool.